This presentation explains how a pressure-reducing regulator works. The first step in understanding how a pressure regulator works is to understand the parts and their functions. In the following slides, we're going to build a pressure regulator part by part from the bottom up. Then we'll review how an assembled regulator functions. As we build the regulator, each described part is highlighted in red. Parts already described become black. This part is the body. The body is the building block of the regulator. The body contains the high pressure and low pressure connection ports. The poppet spring is housed in the body. Spring force loads the poppet spring against the seat. The poppet is the heart of the regulator. The sealing surface of the poppet is tapered to improve flow control. The poppet moves perpendicular to the seat to control and shut off flow from the high pressure side to the low pressure side. The seat is ring-shaped. The seat separates the high and low pressure sides. The seat and poppet function as an orifice. The poppet seals against the inner diameter of the seat, and the seat seals against the body. The high to low pressure drop occurs where the poppet and seat meet. The nozzle clamps the seat to the body. This forms a static seal between the seat and the body, ensuring gas only flows between the poppet and the seat. The diaphragm is the sensing element of the regulator. It is usually a thin metallic material. Its shape is often convoluted to provide more diaphragm movement or stroke. It moves up and down due to the balance of forces between the gas pressure downstream of the seat and the range spring force. The cap assembly houses the stem, adjustment range spring, and diaphragm plate. This assembly provides adjustable force on the sensing element, the diaphragm, to adjust outlet pressure. A friction dampener is common on the adjustment range spring to eliminate resonance. A vent port maintains atmospheric pressure during operation and prevents pressure buildup in case of a diaphragm leak. The vent can be smooth bore or threaded. The cap nut clamps the diaphragm against the body of the regulator. This creates the required force to seal the diaphragm to the body. Ultra-high purity regulators have metal-to-metal seals. The cap nut has a small porthole for leak testing the diaphragm seal after assembly. The wheel or knob enables manual outlet pressure adjustment. Turning the wheel increases or decreases outlet pressure by increasing or decreasing spring load on the diaphragm. The lock nut locks the wheel to the adjusting stem. The wheel is used as an adjustment stop for maximum outlet pressure. The stop can be adjusted by the user to lower the regulator's maximum outlet pressure. The closure covers the lock nut and is removable with a small flathead screwdriver. The closure is printed with increase and decrease rotation arrows. Now that you're familiar with a regulator's parts, we're going to review how a regulator functions. The function of a regulator is to reduce an inlet pressure to a lower outlet pressure. A regulator is not designed to be used as an on-off shut-off valve. In our example, we're demonstrating a single-stage free poppet regulator. Here's the regulator we just built with high pressure and low pressure gauges. The high pressure side is on the right and the low pressure side is on the left. Gas flows from right to left. The regulator is in the fully closed position with knob turned counterclockwise until it stops. There is no gas introduced in the system. Now gas is introduced to the high pressure side of the regulator. The knob is still turned off, so the diaphragm spring is not applying spring force onto the diaphragm. The poppet is closed against the seat, affecting a seal. Gas does not flow through to the low pressure side, gas is contained to the high pressure side. Now the user rotates the knob clockwise to open the regulator. This compresses the adjustment range spring, creating a downward force on the diaphragm. This applies force from the diaphragm to the poppet and moves the poppet away from the seat, allowing gas to pass from the high pressure side to the low pressure side. As gas enters the low pressure side, pressure increases. This force pushes the diaphragm upward, countering the downward force from the range spring. Outlet pressure set point is reached when these two forces are equal. At outlet pressure set point with no flow, the poppet seals against the seat. Now let's review the key information and how a pressure regulator works. The seat and the poppet function as an internal valve. Pressure drop occurs in the space between where they contact. The diaphragm senses the relative forces of gas pressure and the range spring. When the spring force is greater than the force from the gas pressure on the diaphragm moves downward and pushes the poppet away from the seat. The low pressure side gas pressure, in turn, creates an upward force on the diaphragm. This force counters the downward force from the range spring. Outlet pressure set point is achieved when these forces are equal. For more information about APTech products and technical resources, please go to aptech-online.com.